Well, in the 1960s, a German engineer named Felix Wankel was doing some extraordinary work with engines. What he came up with was a completely new type of engine than anything there had been before, and he called it the rotary engine. We know it nowadays as a rotary engine or a Wankel rotary engine in honor of him. Now stick around and I'll show you how it works and why it's so cool. Thanks. Alright, so here's our rotary engine. The first thing to notice is really how simple it looks. I mean, there aren't a lot of moving parts here, as you'll see in a bit, and it's really the beauty of the thing. Okay, so moving around, pretty neat. Now let's slow it down first. Alright, gas particle, do you have a gas particle? And, yeah, there he is, okay, gas particle. So, here's the cycles. We have intake, compression, ignition, and exhaust. So once again, count them. We have 1, intake, 2, compression, 3, ignition, and 4, exhaust. So really, we have a 4-cycle engine here. If you've watched a video on the 4-cycle, or if you've seen 4-cycle engines or know about them, you know those are the same 4 strokes as a 4-cycle engine has. It's just the rotary engine accomplishes them in a radically different way. Well, the next thing to notice is how this thing works. Well, you'll see in the center there's the crankshaft with what's called an offset lobe, which is that kind of off circle rotating around here. And the triangular thing is called a rotor. And you can see as the rotor moves around in a slightly strange fashion there, it causes the crankshaft to rotate. Really quite genius. Oh, look at that. Very nice. Okay, and I mean, there's a lot of interesting things we can see from here. Starting with, what's a little hard to see, but you can see here, in this line, in this diagram, the blue line will represent the crankshaft, and the red line will represent the rotor. And if I start this, you'll see how fast they move comparatively. Okay, so, crankshaft has gone around once already, twice, and 3 times, and the rotor's only gone around once. And then again, once, twice, 3 times. So, for every 1 turn of the rotor, the crankshaft makes 3 revolutions. And this is really more important than you might think. Also next, we have the actual shape of the rotor itself. As you can see, it roughly resembles a rouleau triangle. A rouleau triangle is made by taking equilateral triangle sides and kind of rotating them. And its sweep right here forms the opposite side of the rouleau triangle. Alright, so now let's talk about the next interesting thing. So remember how we found that for every 3 revolutions of the crankshaft, the rotor makes 1 complete revolution. What's cool about this is, since the rotor has 3 sides, for every 1 turn of the crankshaft, the rotor makes 1/3 of a turn. And then, since making 1/3 of a turn, each of its faces is facing the ignition point at that time. So, what this really means is that for every turn of the crankshaft, 1 explosion is occurring inside of there. As opposed to a 4-cycle engine, where it takes 2 full turns of the crankshaft in order to make 1 explosion type thing. This means that for their size, rotary engines pack a lot more punch than a regular 4-cycle engine. So, I think that's pretty cool. Also, what's interesting is the shape this thing makes when it goes around. You can see going around it makes that kind of oval shape, or the shape of the inside there. Now, it's kind of interesting how if we stop this and we make it move a little different, in this case we'll animate these points to, instead of move where the crankshaft is moving 3 times as fast as the rotor, we'll just make it move at random speeds. And you'll see what kind of shape this makes. Oh, it's very neat. Alright, so here we go. So we can trace this point, and let's see. Oh gosh, forgot to trace. Here we go. Okay, here we go. So, see, instead of making a nice little oval shape, it makes a kind of spirograph looking thing. In fact, the only way for it to make that nice little oval shape is if we have the crankshaft moving 3 times faster than the rotor. That oval kind of shape is called an epicotroid, or some pronunciation of therefore. And as you see, with the rotor moving 1/3 as fast, it sweeps out this nice little thing. Ah, very cool, very cool. There are, of course, advantages to this type of setup, and there are also disadvantages. I mean, the main advantage is, as I said before, these things pack a lot more punch for their small size than a similar sized four-cycle engine pistons. Unfortunately, since they aren't sealed quite so well inside of there, there's more blow-by of the exhaust and the gas, so you get less efficiency, and also because of how there's more gaps and stuff, these things can wear out sooner. But I mean, you know, they're so simple there that they're easier to fix and all that, so I mean, there's obviously a trade-off, but I think this is a pretty fascinating type of engine, and I think we'll be seeing more of it in the future. In any case, have a great day, and thanks for watching.